Hello developers, let's start developing. So, Today is the 1st of January, so Happy New Year to everyone. And we still have some stars that we need to get. We have 39, we're supposed to be get 49 stars and then we get 1 star for free, which means that we still have some tasks that we will need to take care of. For example, today we're gonna take the 2nd star of task number 19. So in the first task, part of the task, we did some workflows for a given set of elements, and we have 4 categories, which now I'm gonna start calling dimensions because that's gonna be important later on. So we have 4 dimensions that are basically independent of each other, and each part has a value from 1 to 4,000, and we run the workflow and just see if something is accepted or not. But now we want to pre-compute those sets. So that means that instead of having a bunch of workflows that we're running, we can just have a lookup table. That is a good thing, and that often happens in production scenarios. When we have a set of rules that we want to run, we might pre-run them on every possible input, and then we just replace something that could be a very complicated rule engine with a simple lookup table. That works. But the problem is if we have multiple dimensions, and we often do. Um, you can think of these dimensions, for example, if we have an invoice, the invoice can have a tax bracket, it can have the number of items, it can have the month that is issued, and something like 10 different parameters that are basically independent of each other, which means that we can treat all those things as a dimension. So we can treat that invoice as a point in a 10-dimensional space. Here we have 4 things, so we only go to up to 4 dimensions, which means that we just need to find out the volume which will be accepted. The volume of the 4 dimensional thingy. I think it's a hyper rectangular parallelepiped or something like that, but I will call those hypercubes. So we need to find out which hypercubes get accepted and basically get their volume. The volume of a hypercube is basically multiply all the sides. Just as for a volume of a rectangle is A times B. And here we will have X times M times S, A times S, because our 4 dimensions, of course, are called Xmas. So now we just need to consider only the workflows. So our input, which is already parsed, it was quite hard to parse. We just need to take the workflows. So we're starting with the small input. So this is the part we're interested in. We're starting at a workflow called in, and we need to basically do some things. So what is our space? What is our initial hypercube? Is a, well, let's define that as an interface. So we have a hypercube and we have not that, but x will have a minimum and a maximum value. And so will m, and so will a, and so will s. So these things actually represents a hypercube. So our initial hypercube will be this thing, only we will have a little bit of difference of sides because we are just gonna take our hypercube and process it. And what will the processing be? So let's take a single rule. Something like, yeah, this one. So here we have a rule that says if this go here, if this go here, if that reject, if otherwise accept. So this rule kind of works, restricts our hypercube, splits our hypercube, so to say. So it splits it into everything that goes to 1 and everything else. So we can take that part of the hypercube that fits this. It says M is any, A is any, S is any, X is less than 10 or more than 10. So we take that part of the hypercube and then we send it off to 1. But that means that the rest that we have is should also be separated. What I'm trying to avoid here is something called an inclusion-exclusion problem, because let's have a rule like this, for example. Let's have it all of them. And let's, instead of 2000, let's say we go to 40, because this is nicely in the middle of it. So if we go up to 40, that means that our area is actually 40 times 40 times 40 times 40, 2.5 million spaces. So we say we accept everything that has x greater than 20. So that is half of that, so that's 1,280,000. And we accept everything that has an m over 20. And that is also that number. And we accept everything that has a over 20, and that is also that number. So that means out of 2.5 millions, we are accepting something like 3.7. This is obviously wrong. Why? Because a certain set of these will have both x over 20 and m over 20. So we are counting them twice. Or if they have x over 20 and m over 20 and a over 20, we're counting them 3 times. So what is the common approach here is that we will add this up and then remove all the ones that are double. But since if they match all 3 criteria, we will remove them once, we will remove them twice, and we will remove them a third time as well. We need to, those that match 3 times, we need to add them back again, and so on and so forth. And I really don't want to do that. So what I will do is here, after we process the first rule, we will separate the hypercubes. So we have a hypercube that is bigger than 20 and a hypercube that is less than 20. And that second hypercube will have this many total. So now when we say m bigger than 20, we are actually not doing that, but we are doing 512,000. Because that's half of that. And then the rest, which is also 512,000, we're passing to this rule, which again will half it, and it will just say 256,000 or something like that. So that is what we're gonna do with our hypercubes. And if we add this all up, we will get how many we actually pass. Which means that we need to have a method Oh, a workflow is a map. So we actually need to have our workflows. Yeah, this is a record to a string of workflows. So workflow array is this. Is this an array? No, this is, yeah, it is. Since we're no, this is not a map, this is an actual record. So we can just do a for workflow of workflows of VF array. We're gonna need to, do we need to do it that way? No, I think we need to have something like this. We need to actually run the workflow. So we're starting with the initial workflow of in. So if the workflow is in, we get that workflow. And instead of doing this, I will call this method. Execute on this hypercube, but don't execute on this hypercube, execute on this array of hypercubes. And you will return basically next hypercubes. And then we will do something else. So, an execute will be a magical method. Of course, we're going to implement it later. That will take a set of hypercubes and for each of them try to run the set of rules and split them as they need to be split and return the result along with the workflow that will happen. So that means that we need to declare this method. And that's gonna be in the hypercube class, in the workflow class. So we're getting a set of hypercubes and then we need to execute them. Of course, this will have for each, it's gonna happen independent for each hypercube. And this says, well, maybe you want to have a method for that. Indeed I do. Because this is a very common pattern when we have to process a set. We actually just have something like this code in the set processing thing. And here we can say we are focusing on a single hypercube. So we need to see whether our rules match. So we will just have to move the cube through our rules, potentially trimming it. So that means we need to loop through our rules. Execute the rule. Or I will actually say that in this way. So the rule itself can have another abstract method, execute, on the hypercube. We have no idea what it will return. Let's say a hypercube array. So for the everything rule, we will have a execute method. And this basically doesn't do anything. So an everything rule accepts everything. But one more thing. I will move this interface up top. We're gonna need to know what to do next. So we will have a type called hypercube result, which will be not that. Basically, we will have a hypercube that's a hypercube and not a count that we don't care about, but next, which is a string, which will be the name of the thing that we're supposed to do next. So we have our hypercube result, and so this will be an array, hypercubes. This will return a hypercube result. So for the everything rules, we need to return a hypercube result. And what is the result? We are just executing everything because we are matching on everything, which means if we get a hypercube, we are moving that hypercube, all of it, totally, in the next stage. So that's something like this rule. If we get to here, execute the CRN workflow, yeah. So that is kind of easy. We just need to return. We return an object. Yeah, the hypercubes is the array of this hypercube, and this is the next. Oh, a single hypercube will have a single thing. So no. This means we are sending that hypercube to that thing, and so we're not returning a single hypercube result, we're returning an array of hypercube results, and that array is, well, in this case, it only has a single item, and that is the hypercube and the target. So that's all that we need to execute. Now, what happens for this? So each rule is only a single thing, which means that we will have at most two hypercubes. We might match it completely. Let's check that. So if, no, we're not going to go this much in detail, of course we can. If we are going that way, the less way, that means that we are applicable if and only if if the minimum is over the value that we want to say less than, then this rule is not applicable. Also, this is not an execute method. This might be an execute match method. Something like this, because it will return up to two items. So our hypercube result is not that. We still haven't hit the nail on the head. Yep, I like this better. So when we are executing a match on a hypercube, we will say, once more, we're doing it this way. So we will say we are matched on this hypercube, not matched on this hypercube, because we might need to split it, and this is the next thing that you should do. So this, and let's re-implement this. So it's not an array and it doesn't have a hypercube property. It has a matched, and unmatched is not hypercube because we will have a question mark here and here. Actually, I don't like a question mark because that means undefined, but I will say this can be a hypercube or null. Unmatched is null because we matched all of it. So in this case, if R, we are saying, we are checking if something is less than, let's imagine that the category or the dimension is X. So if we're saying this rule only applies to if X is less than 20 and our minimum value is 50, we have nothing to do, which means that we just return matched is null, unmatched is hypercube, next is the target. Otherwise, yeah, is the whole hypercube matched? Otherwise, it's in the other direction. If the maximum value of the hypercube is less than the value, that means the whole hypercube is matched. We are saying x is equal to is less than 2000 and we are from 100 to 200. We're matched. And then it is matched, that is unmatched, this is the target. Otherwise, yes, we're gonna need to split the hypercube. So the matched will be, everything else stays the same, but for this category that we're doing, let's call it X, that means that the minimum will still say the minimum, but the maximum will be the value minus 1, because we are only doing strict inequalities. And of course, the unmatched will be the other part. The minimum is the value of the rule, and the maximum is the actual maximum that was already here. And now we just need to return the matched and the unmatched. And I will actually extract this. Where was the refactor menu? Yep. No. But this will be a private method because this doesn't actually check anything. It just does the thing it does. So return this dot execute less on this hypercube, else execute more on this hypercube, which means that we are one private method short. Now we have the other way around. So we need the more things. So if the we will need to do some thinking, because if we just plainly so we have a rule that says x is bigger than 20, and if our maximum is less than or equal to 20, then the rule is not applicable. Otherwise, if our minimum is bigger than the value, So we're saying x bigger than 20 and our minimum is 200. The whole hypercube is matched. Otherwise, the matched part is actually we're gonna need to swap this. So the unmatched part is from the minimum to the value, and the matched part is from the value plus 1, because if we say x bigger than 20, this needs to be plus 1, and this is the unmatched part. From the minimum up to and including the value. And then we return the matched, the unmatched, and the next target. So now let's go back. We have an execute match on our rules. The rules are finished. We need to see what the workflow does. So on that rule, we are gonna execute match and we're gonna get a hypercube result. So we're gonna need results, which is an array. So if we matched something, that means we don't need to do any more work with that part. For example, if we matched everything, we're just done. So we are matching on our active hypercube, and that hypercube will return with next matched and everything else. So so the matched we need to stop processing, but the unmatched we need to continue processing. And what is the problem here? This is a hypercube and this is a constant. Yeah. So if we have an unmatched part in whole or in part, we're just continuing with that. Do we actually need the next thing? We kinda do. We need a type that only has these two. Well, I will rename this because this is a hypercube rule result. And we will have another which we will actually call hypercube result, which is a hypercube. And a next. So from the workflow, that is the result type that we're gonna get. We're gonna get an array of actual hypercube results. So here we can just say hypercube is match.matched and next is next. And this is the value that we will be pushing on the result. Otherwise, continue, and then we get an unmatched part, and then we get to the everything rule, which definitely doesn't return an unmatched part. because it matches everything, which means that our flow will stop. And now we are returning for a single hypercube, we will return the results. And this will be a set of things. But if we get multiple hypercubes, we just need to have this hypercube result is this, and since we want to have them and we want to have them flatly, we're gonna do that, and then we can actually return the results. So let's see what happens now. We are giving this a hypercube and getting the next hypercubes. So what do we need to do with the next hypercubes? We need to continue processing them because each hypercube result has that. Maybe we want to do this. And we're gonna need to have we have accepteds because these are the ones that are accepted. We have no idea whether this is accepted or not, but we need to see this. So, well, and this is hypercube results, let's call them. Oh, something like this. Which means we always start this with a single hypercube. Let's see. So, we take out a hypercube result, and if the next is accepted, then we just add it to the accepteds. If the next is rejected, then we simply continue, because we don't really care. And let's just say continue here. Yeah, I like it better this way. So this is cleaner. So if we are accepted, we are accepted. If we're rejected, good riddance. Otherwise, workflow, not this workflow. This is yeah, let's just do that. And now we need to get that workflow. Yeah, that is the workflow for this result that we need to do. Execute it. And this is the next results. And inside the hypercube results, we're pushing all the next results, which can be one or two or many. Nobody knows, nobody cares. The next results are an array of hypercube results, and this is an array of hypercube results. What? Oh, which means that we don't really need this. Maybe this is enough. We can just say execute hypercube because we are running them one by one. Note that execute is a bad name because it doesn't actually do anything. We could just as easily call it do. So at the end, we just need to actually accept it. Yeah, do something like this. Great for Copilot, but to be honest, I don't actually understand this. So I will do a simple for loop. For off loop, of course. Result accepted. Hypercube. Because that's a hypercube. Inside the accepted, yeah, we only have hypercubes. X dimension is that. M dimension. Actually, we can call this X size. And with Copilot, it's actually easier to do this. And then we say hypervolume. We can just call it volume, but this is hypervolume. And of course, we have a total hypervolume, and then we add it to that, which means that we can return it. Of course, we can do this with a one-liner, but if I had a bug in that one-liner, I would never know. So let's run it. I feel like this has a chance, a significant chance of working. It has a significant chance of exploding as well, or giving us an incorrect answer, but let's just see. It gave us this huge number. Is that the correct number? Yeah, it is. Let's see what it actually does. We might want to debug it a bit to see how the hypercubes are moving through the system. But let's see first that maybe we have a correct answer. I would actually expect the answer to be a bit less than the demo input, just because we have more rules that will are able to reject it. Let's see if this huge number is correct, and of course it is, and now we have 40 stars, only 9 stars left. So we got number 19, but it seems that the animation actually is quite linear, which means that until I get task 17, I'm not gonna see how it progresses. And that is a problem because, to be honest, I'm kind of stuck on 17. I tried to do an implementation, I tried to speed it up, I managed to speed it up, and it's been running for a couple of days, and it's gotten to this value basically at the price of, yeah, these are 1 billion and 59 million calls. So I think that I will kill it now and try to implement a better solution. I already read up on how to actually implement Dijkstra for this method, for this task, and we'll do that in another video. For now, this will be it. We're getting to a point when we are. We might also want to take a look at how long everything takes. So for now, we just need to kill task 17. Yeah, it is. And if we run npm run all, it will run all the tasks that we have solved. So out of the 49 tasks, we have 40 solved. And unless I'm mistaken, they are all running with the proper input. Yeah, some of them are where we have zeros for this, that means it's not implemented. But you can see where we have the issues that basically task 12 part 2 is taking 31% of our running time. I don't think this is optimizable too much. Task 10 as well, task 16. But the task that we actually solved this time, it's exactly 0% of everything. Even day 1 takes more time. And additionally, we can see that the most complicated thing, the thing that spends its most time on, is actually parsing the input because we have a lot of code. It's not, some of these have more input parsing, but they are basically ingesting huge files. This is a small file, but with complicated parsing. Anyway, don't forget to click like, subscribe, whatever, and talk to you later.